Hello everyone, welcome to a cosmic journey into the captivating world of Uranus. Get ready to embark on an extraordinary adventure as we explore the enigmatic seventh planet of our solar system. The title of our video is Uranus, a frozen ballet in the outer solar system. Uranus, the seventh planet from the Sun, is named after the Greek god of the sky. Uranus is the third largest planet in our solar system with a diameter four times that of Earth. Uranus has a diameter of approximately 51,118 kilometers, 31,763 miles, while Earth has a diameter of about 12,742 kilometers, 7,918 miles. The atmosphere of Uranus is composed primarily of hydrogen and helium with small amounts of methane, which gives the planet its distinctive blue-green color. Unlike most of the planets in our solar system, Uranus is tilted on its side, rotating on an axis almost parallel to its orbital plane. This unique orientation is thought to be the result of a massive collision early in Uranus's formation. Uranus has a thin set of rings consisting of dark particles and debris. These rings were discovered in 1977 by astronomers using the occultation method. The rings of Uranus are much fainter than those of Saturn and were not observed by telescopes until relatively recently. The five main rings of Uranus are named after astronomers who made significant discoveries about the planet: Gall, Leverrier, Lassell, Arago, and Adam. The atmosphere of Uranus features a large number of cloud layers which are made up of different combinations of gases and compounds including methane, ammonia, and water. Uranus, like all other planets, experiences seasons. However, the seasons on Uranus are quite unique compared to those on Earth. One of the main reasons for this is the extreme tilt of Uranus. While Earth has a tilt of approximately 23.5 degrees, Uranus is tilted at an angle of about 98 degrees. This means that one pole of Uranus is pointed almost directly at the Sun while the other pole is in constant darkness for half of the year. Due to this extreme tilt, Uranus experiences long periods of daylight and darkness during its orbit around the Sun. Each pole of Uranus experiences 42 years of continuous daylight followed by 42 years of darkness. As Uranus orbits the Sun, the different hemispheres experience varying amounts of sunlight, resulting in changes in temperature and overall weather patterns. The transition between the light and dark hemispheres creates interesting climatic conditions and atmospheric phenomena on the planet. Due to limited data available and the long duration of Uranus seasons, our understanding of its seasonal changes is still limited. However, missions like Voyager 2 have provided valuable insights into the atmospheric dynamics and climate patterns of this fascinating gas giant. Uranus has a hot, dense core made up of rock and metal surrounded by a layer of icy mixtures of methane, ammonia, and water. The core temperature of Uranus can reach up to 9,000 degrees Fahrenheit, 5,000 degrees Celsius. The methane in Uranus's atmosphere absorbs red light, giving the planet its characteristic blue-green appearance. The presence of methane also causes Uranus to emit a faint amount of infrared radiation. Uranus has 27 known moons, the largest of which are Titania, Oberon, Umbriel, Ariel, and Miranda. The largest moon of Uranus is named Titania after the Queen of the Fairies in Shakespeare's A Midsummer Night's Dream. Titania is the eighth largest moon in the solar system with a diameter of about 981 miles, 1577 kilometers. The second largest moon of Uranus is Oberon, named after the king of the fairies in Shakespeare's play. Oberon is the ninth largest moon in the solar system with a diameter of about 760 miles, 1224 kilometers. Umbriel is another major moon of Uranus. Ariel is a moon of Uranus named after a character from Shakespeare's play The Tempest. Miranda, another moon of Uranus, has one of the most varied and geologically active surfaces in the solar system. The surface of Miranda shows evidence of past tectonic activity with large canyons and cliffs. The bright patches on the surface of Miranda suggest that the moon has experienced cryovolcanism, volcanic activity involving water and other volatile substances. Miranda has a highly diverse terrain with a mix of heavily cratered regions and smoother younger areas. The diverse terrain of Miranda suggests that the moon has undergone significant geological processes in its history. The moons of Uranus are thought to have formed from a disk of gas and dust surrounding the planet during its early stages of formation. The Voyager 2 flyby provided the first detailed images and data about Uranus's moons, revealing their varied surfaces and characteristics. The Voyager 2 mission discovered several new moons of Uranus, including Cordelia, Ophelia, Bianca, Cressida, Desdemona, Juliet, Portia, Rosalind, and Belinda. The moons of Uranus have been extensively studied using telescopes as well as data from the Voyager 2 flyby. The Voyager 2 spacecraft took about 9 years to reach Uranus after its launch in 1977. Uranus has not been visited by any other spacecraft since the Voyager 2 flyby in 1986. Uranus is located about 1.8 billion miles, 2.9 billion kilometers away from Earth on average. The composition of the rings of Uranus is not well known, but they are thought to be composed of dust, rock, and ice particles. Uranus has a total of 13 rings, which are named after characters from Shakespearean plays. The rings of Uranus are thin, ranging in width from a few kilometers to several hundred kilometers. The largest ring of Uranus, known as the Ring, is located closest to the planet and is about 20 kilometers wide. Uranus has a faint system of shepherd moons called Cordelia and Ophelia that help keep the rings confined and in place. The moons of Uranus have distinct orbits, with some traveling in a prograde direction in the same direction as the planet's rotation, and others in retrograde direction opposite to the planet's rotation. Uranus is composed primarily of gases such as hydrogen and helium, similar to Jupiter and Saturn. These gases have reflective properties that contribute to the planet's overall brightness. Additionally, Uranus contains trace amounts of hydrocarbons, such as methane, which also reflects sunlight, adding to its overall brightness. The atmospheric pressure on Uranus is much higher than that on Earth. It varies with altitude, but on average, it is around 1.2 million times greater than Earth's atmospheric pressure at sea level. To put it into perspective, Earth's atmospheric pressure at sea level is approximately 101.3 kilopascals, while Uranus has an average atmospheric pressure of around 120 kilopascals at its cloud's top. This is equivalent to approximately 1.2 bars of pressure. However, as you descend deeper into Uranus's atmosphere, the pressure increases exponentially. At about halfway to the planet's core, the pressure can reach thousands of kilopascals, which is comparable to the pressures found in the depths of Earth's oceans. This immense atmospheric pressure on Earth is a result of the planet's massive size and its composition of hydrogen and helium gases. It creates extreme conditions that make the exploration of Uranus a significant challenge for scientists and spacecrafts. The winds on Uranus can reach incredible speeds, with some gusts exceeding 900 kilometers per hour, 560 miles per hour. These high velocities make Uranus the third windiest planet in the solar system after Neptune and Saturn. Unlike the eastward or prograde winds found on most of the planets in the solar system, the winds on Uranus blow in the opposite direction. They are predominantly westward or retrograde near the equator. Uranus exhibits zonal winds, which means that the winds blow in distinct bands parallel to the equator. These bands are referred to as belts and zones. The belts are darker and correspond to regions of lower temperatures, while the zones are brighter and have higher temperatures. The strongest winds on Uranus are found in its upper atmosphere, specifically in the region known as the stratosphere. The wind speeds decrease as you move deeper into the planet's atmosphere. The study of Uranus and its system of rings and moons will continue to captivate scientists and inspire further exploration of the outer regions of our solar system.